In this question, a and b are real numbers, and a is non-zero. When the polynomial x squared minus 2ax plus a to the 4 is divided by x plus b, the remainder is 1. The polynomial bx squared plus x plus 1 has ax minus 1 as a factor. It follows that b equals one of these possible options. Okay, this polynomial division stuff and factors and remainders and all that, there's a lot of formulas that apply here that I just sort of don't have memorized, but I mean I know what the concept means by things being multiplied or polynomials being divided. So when the polynomial x squared minus 2ax plus a to the 4, when it says when it's divided by b, the remainder is 1. This says that this is equal to some polynomial in x times x plus b plus 1. That's what it means for the remainder to be 1. Additionally, we're told that bx squared plus x plus 1 has ax minus 1 as a factor. So this is equal to qx times ax minus 1. Okay, so p of x and q of x are themselves also polynomial, and I guess we can see that they have to be linear polynomials. Okay, and we know that a is not equal to 0. Doesn't say anything about positive or negative. Okay, and so let's we have to now figure out all the possible values of b. So perhaps I can find values of x to substitute into these equations so that certain terms go to 0. So let's let x equal 1 over a. Okay, and we'll look at the second equation. So that's equal to 0. So this says that b over a squared plus 1 over a plus 1 is equal to 0. And if I multiply through by a squared, I get b plus a squared is equal to 0. Okay, now let's do something similar up here. And let's let a be equal to x be equal to negative b. Then from the first equation, we have that b squared minus 2ab, or I guess, is it plus 2ab? Yes, plus 2ab plus a to the 4 is equal to 1. Okay, does this help us? I mean, maybe one thing we could do here is we could solve for a in terms of b, and then substitute the solved values of a down in there, and see what happens. This could, I mean, a question like this potentially could lend itself to some guessing and checking. I typically don't like to approach these multiple, or not guess and check, but process of elimination from the options given. I typically like to work these questions out in full rather than using process of elimination. You know what I could do is I could take this equation and write a squared is equal to negative a plus b. So then a to the 4 is equal to a plus b squared. And substitute that down here and see what we get. So we have b squared plus 2ab plus a plus b squared is equal to 1. So this gives b squared plus 2ab plus a squared plus b squared plus 2ab, 1. It doesn't really seem to help very much. I could then substitute for a squared. A squared is equal to this. I think, in the interest of not banging my head against the wall for an hour, I think I might just try to use process of elimination here and just test all of the possible solutions given to us. I mean, we have two equations that have to be satisfied, this one and this one. So if I choose a value of b in both of these, I just have to make sure that it's possible that there is a value of a. So difficulty is, okay, let's take this first equation, b plus a squared is equal to 0, and solve for a in terms of b. So a will be equal to -1 plus or minus the square root of 1 minus 4. Oh, hold on. 1 minus 4b over 2, right? Do that right? -1 plus or minus 1 squared minus 4 times b over 2. Okay, so we need, in order for anything to make, for this square root, for the discriminant to be positive, we certainly need b to be less than 1 over 4. So this eliminates quite a few of the options, that we're given. In particular, it eliminates C, D, and E. So I now only have to look at 2 of the options. And let me copy down the second equation briefly. B squared plus 2ab plus a to the 4. That's equal 1. Okay. So let's look at the first option then. So option A is that b must be equal to 1. This implies a is equal to negative 1 plus or minus the square root. Oh, no. Yeah, that option is eliminated as well. Sorry, a is also eliminated. We cannot have b is equal to 1 because we must have b less than or equal to 4. So the answer by process of elimination is b, that we must have b equals 0 or b is equal to negative 2. And we should be able to check that this works. So what I'm going to do is I'm going to substitute b is equal to 0 in here, and then find that value of a and show that it satisfies this, and then we'll do the same thing for negative 2. So with b is equal to 0, a is equal to negative 1 plus or minus 1 divided by 2. And remember, it said that a is not equal to 0. In the original part of the question, it says a is not 0. So this says that a must be equal to negative 1. And then we can check here quickly that that certainly works, right? If b is equal to 0, these two terms are gone, and a is negative 1 satisfies this. So that works. Let's try b is equal to negative 2. So then we have a is equal to negative 1 plus or minus the square root of 1 plus 8, which is 9, divided by 2. So a is equal to negative 1 plus or minus 3 over 2. So a is equal to 1, or a is equal to negative 2. Okay, and let's test again everything here. So b is equal to negative 2. So b squared plus 2ab plus a to the 4. When b is equal to negative 2, this gives us 4 minus 8a plus a to the 4. And when a is equal to 1, this gives 4 minus 8 plus 1, but that's not equal to 1. Oh, sorry. Little mistake here. B is equal to negative 2, so this is plus 4a plus a to the 4. Okay, so if a is equal to 1, certainly this equals 1. And if a is equal to negative 2, it doesn't work, but we don't need all the values of a to work. We just need to find which values of b actually work here. Yeah, when a is equal to negative 2, this is going to be a large positive number. What is that? That's 16, and then 16 minus 8 plus 4. I'm not sure. But yeah, at least one of the values of a does work when b is equal to negative 2. So the only possible values of b that were allowed, according to the options given here, are these two. I mean, the main key that I used here to find this is that b must be strictly less than 1 over 4. Well, I guess it could be equal to 1 over 4. But yeah, I don't immediately see the way of doing this directly without using process of elimination. I mean, we have two equations in a and b, so in theory we can solve for those. But maybe there's a nicer way of doing this, like we might be able to figure out what another thought that I had early on, but I thought it would be very messy, is to write out in general what qx and px are, you know, something like qx is equal to q1x plus q0, and p of x is equal to p1, sorry, these aren't polynomials, p1, all these numbers, these are all just constants, p1 times x plus p0. And then maybe using these relations, we could solve for maybe not all these coefficients, but some of them. And then deduce, you know, maybe get other equations that A and B have to satisfy and use those to solve. Yeah, not too bad of a problem. You know, again, there might be other ways to do this fully, but writing down the definition of what it means for a polynomial to be divided by something else and have a remainder, that was kind of the first key here. If I have more to say, I'll write it down in the description. Thanks for watching.